Okay, great. Hi there, I'm Melissa. I'm a co-PI on the project supported by the Oregon Ocean Science Trust, and I have a background in eelgrass ecology and carbon biogeochemistry and restoration.
And I'm Brian Katz. I'm the other co-PI on the project, and my background is in shellfish aquaculture livelihoods.
Yeah, so we are presenting some of the preliminary results and final deliverables from our project to develop community guidelines for sustainable co-management of submerged aquatic vegetation and shellfish in Oregon. So this project, which was supported by the Oregon Ocean Science Trust and a House bill, sought to develop these co-management guidelines and to give it some framing. What we mean by SAV and submerged aquatic vegetation is any SAV. Most typically that means seagrasses because that's what's interacting in space most often with shellfish in our bays and estuaries, but it can also mean other marine macrophytes. And similarly with shellfish, it can be inclusive of lots of different kinds of shellfish. Most typically that means oysters, either native or farmed, but there's a high level of spatial interaction with commercial oysters and eelgrass. So often that is what we have focused on. The main take-homes of the project were to host a workshop, which was done in January of 2024, produce a guidance document to help direct what these guidelines should look like for the state of Oregon, and also to visualize all of this information in space with a mapping tool that Brian will present. And then ultimately, we hope to put some of this into peer-reviewed publications. So framing some of the context more broadly, the US consumes a lot of seafood, but that is mostly imported. And so that leaves us with a large seafood deficit, $17 billion seafood deficit nationally, which leaves space for sustainable expansion of aquaculture to fill that in. Aquaculture currently contributes only a small portion to the total seafood consumption, but that proportion is growing and it reduces pressure on wild-caught fisheries. So if we can expand aquaculture sustainably, it's a good option for local sustainable businesses and to sort of increase economic opportunities. And it shows from our preliminary survey results that Oregonians do support the sustainable expansion of aquaculture within the state. But that means that, particularly with a changing climate, the interactions between SAV and shellfish and other multi-uses of coastal zones will increase. And so that sort of merits good marine spatial planning. And it also, we can look towards being more adaptive and anticipating those changes rather than reactive to when they happen. So SAV and shellfish, though, can interact in space in complex ways. That could be ecological or environmental ways, but it could also be in the context of policy and management. So things like disease reduction as positive environmental interactions both support biodiversity, water filtration, water quality, potential for OA amelioration and carbon storage and the blue carbon aspects of seagrass. But there are also negative environmental interactions, so changes to the sediment, changes in light availability, and similarly with the sort of realized management of shellfish aquaculture and seagrass, there can be negative interactions from the gear, most significantly for shellfish aquaculture, but also potential positive interactions. So that gear can simultaneously, in the right context, favor eelgrass. So clearly, all of these interactions need to be taken into consideration if we're going to effectively co-manage these things with a goal of trying to maximize these positive interactions and minimize these negative interactions. Of course, we need to manage these habitats now, and we don't have all of the information in our hands. And so it leaves us sort of with the charge of using the best available information to manage things in the best way we can. And these are just some of the big overarching questions within that. So how are we supposed to balance these diverse goals of the various coastal stakeholders and rights holders and interest groups? And how do we manage aquaculture without sacrificing environmental protection? It doesn't need to be either or. We can endeavor to do both, but also we have to do it somewhat quickly. So like I said, the main points of the workshop were to inform guidance on SAV resource protection in Oregon. How do we do that now? What needs to change? Look across those user groups to gather information from all of those and build consensus on what those goals should look like. And then also, where do we need to go scientifically? What is a huge gap that needs to be addressed in order to improve that management? And I will pass it over to you.
Great. So we conducted an online survey. We were interested in understanding the current perceptions of user groups in Oregon. So in particular, we wanted to know, what do people believe, support, or have questions about with respect to SAV and shellfish in Oregon? And how can that information be used to frame management? So our survey results resulted in 35 respondents coming from a variety of sectors, including academia, natural resource management, recreational harvesters, SAV restoration practitioners, commercial aquaculture growers, and advocates or NGOs. And as Melissa alluded to earlier, most people on our survey agreed that Oregon should expand sustainable aquaculture. And digging into some of the specific questions that we were asking, in terms of threats from ocean acidification and hypoxia, most people agree that OAH poses a threat to shellfish, and that SAV could be an important resource for mitigating the impacts of OAH on shellfish. So it would appear that co-location of shellfish and SAV seems like it would be a viable tool to improve adaptation and resilience to climate change, right? Well, problem is that co-location benefits are perceived more towards SAV helping shellfish than shellfish helping SAV. And it appears there's greater social division on the potential for shellfish to benefit SAV, as you can see with the mixed opinions on the graph on the right here. But regardless of any differences in perceptions, there are perceived mutualistic benefits to co-location for both shellfish and SAV. So SAV is perceived to ameliorate OAH and foster ecosystem resilience. Shellfish are perceived to improve water quality and provide nutrients, and both shellfish and SAV are perceived to create habitat and stabilize sediment. But there are some downsides to co-location as well. While SAV is perceived to hurt shellfish through nighttime respiration that releases CO2, a complication to its OAH mitigation capacity, and through smothering, which may be more of a concern in the case of non-native eelgrass. But there are a number of perceived impacts of shellfish on SAV. However, you'll notice in the graph on the right that while the perceived impacts of SAV on shellfish, are primarily environmental in nature, in the graph on the left, uh, the perceived impacts of shellfish on SAV, graph on the right, are primarily related to aquaculture practices. And that can show how it's not so much the shellfish species themselves that are problematic for SAV, but rather how the shellfish resources are co-managed with SAV that can affect these perceptions of harm to SAV. And there's still a lot we have to learn about shellfish and SAV interactions, particularly in field environments where conditions vary dramatically compared to controlled laboratory environments. So in particular, we need to improve our understanding of spatiotemporal dynamics and the relative influence of multiple stressors. Additionally, research needs to investigate the carrying capacity of ecosystems to support both eelgrass and shellfish populations, and to characterize the effect of spacing aquaculture in terms of effects on both eelgrass and livelihoods. Now, there appears to be a social division regarding the permitting of shellfish aquaculture near SAV, with nearly an equal amount of people being both for and against existing policies that exclude aquaculture practices from occurring in locations known to have eelgrass. But on the other hand, there's strong consensus on the potential for some harvesting practices to have greater impacts on SAV than others, in particular mechanical harvesting of bottom culture oysters. So what can be done to reduce conflicts and improve co-management? Well, traditionally policies have promoted spacing aquaculture away from SAV, but that policy can become complicated to interpret with respect to the transient nature of SAV. Our survey respondents appear to recognize the importance of implementing flexible adaptive management practices that routinely monitor locations for changes to SAV and to assess impacts from aquaculture as well as multiple stressors and make appropriate adjustments to management. So in an adaptive system, there may be contextual instances where policies become more or less stringent based on how trends are monitored and evaluated over time. In addition to the online survey, we conducted interviews, including with growers, and here are some of the quotes from those interviews. One grower said, "We have locations where uh, we have planted oysters and the eelgrass comes in. We've even seen areas where we've removed shellfish gear due to permitting and seen a reduction in the amount of eelgrass." In another quote, farm is asked to have no impact on SAV and a negative change is seen. Well, what would the result be from if burrowing shrimp move into an area and oysters and eelgrass are both displaced? Is it the grower that would be held liable? The environment is dynamic and there are significant changes in eelgrass and burrowing shrimp on an annual and seasonal basis. And finally, press disturbance is like long lines that are too tight. At some point, you're going to affect the ability of the eelgrass to get light, and therefore you're going to shade it out or it's going to silt over because the water slows down and the silt settles. To me, that's a regulation that makes sense. We can say, okay, we're going to be 2.5 feet wider, or whatever that number might be. And those are the kinds of regulations that allow oyster aquaculture and still allow for the protection of submerged aquatic vegetation. And aside from that guidance document deliverable, our project developed a web mapping tool. Users of the mapping tool can explore spatial data on shellfish and SAV in Oregon, our online survey results, and the comments collected during our workshop's mapping activities. I will just briefly load the map so you can see it is publicly available. So when you load the map, you'll see an explanation of the survey and some of the charts that you see. So on the top here, you have our survey results. These can be broken down by user groups. So if you want to see just the researchers' responses compared to the managers' responses or the commercial shellfish responses, as well as by location. If you wanted to look at a specific estuary in Oregon, you can explore the data in that way.
They can hit the question mark test.
Yes, and there's a list of all of our questions that we asked in the survey available here, as well as these coded themes. So you can click these buttons to explore that. You can also explore the spatial overlay data that we have, things like eelgrass beds, shellfish aquaculture leases, recreational shellfish areas, etc. And finally, you could view the workshop comments that we collected in breakout group activities. We had 4 different breakout groups on these topics. We asked a variety of different prompts in these mapping activities. And if you wanted to kind of hover over these circles by a specific prompt and breakout group, you can explore what people were saying in our workshop. So now to bring it back to our presentation, excuse me.
Mhm.
Okay, I will turn it back over to Mel.
Great. So as a result of the sort of literature review that we conducted, all of the interviews that we conducted with individual stakeholders and user groups, and the feedback we compiled from our workshop, all of those were used into a best management guidance document. And within that document, which has, quite a bit of detail, there are also some recommendations that we've developed. And those are sort of a high level summary of those are presented here. There's a lot more detail in the report, but some of those recommendations are to, advance key scientific questions and improve data-driven understanding of the way that SAV and shellfish interact with respect to shellfish culture. So for example, what conditions facilitate the expansion of eelgrass populations into shellfish culture areas? That information is essential to understand how we can support that and how we should be guiding shellfish culture practices. Similarly, how do burrowing shrimp or other nuisance species, but in particular burrowing shrimp, interact with shellfish culture and SAV habitat, and how can we co-manage those? So understanding those interactions. One of the growers alluded to that. If eelgrass is lost, is the driver the shellfish? Is it the burrowing shrimp? Is it some interactive effect between all of them? And that all requires science. And then similarly, understanding how the eelgrass reproductive cycle interacts with disturbance from shellfish harvest and the timing and frequency of that harvest or disturbance. So are there ways that we can time the harvest cycle around the eelgrass reproductive cycle such that we can minimally disturb their ability to repopulate following disturbance or in other areas of the estuary? And then sort of taking a critical look as we get more scientific information in particular about what harvest practices are used. So off-bottom culture can be a lot less impactful than on-bottom culture. It can also be less susceptible to things like burrowing shrimp. But of course, changing a culture method can be economically costly for a shellfish farmer, and small farms can bear disproportionately those costs relative to large farms. So within all of these recommendations, the devil's in the details. Similarly, discourage mechanical harvest, like dredge practices. But if it is used, there are ways that it can be done most sustainably. So again, looking at ways to minimize the impact on eelgrass if we could time it around eelgrass populations in such a way that may be least impactful. And then take a close look at stocking density and spacing, which was also alluded to in some of those quotes. Similarly, within a lot of this project is challenges with monitoring protocols and data access, and we're sort of at time here, but the shellfish harvest data is difficult to track down, and that makes management difficult. If you don't know where the harvest is happening, how frequently, what methods, and relatedly, where is the eelgrass? Is it moving around? If eelgrass is lost in a particular area, is it a result of a harvest practice? Is it indicative of a larger estuarine-wide loss? Is it a result of burrowing shrimp? If we're going to manage all of these things effectively, we need the monitoring data to support that. And that's true of recreational harvested species too, including Olympia oyster populations in those monitoring programs. And then there's regulatory options. So just increasing the relationship building between commercial shellfish operators and the regulators, using best available information in order to design policies that are adaptive and responsive and allow flexibility in growers to environmental change. We didn't touch on it much here, but recognizing tribal sovereignty to manage their own marine resources, and then, incorporating all of this into estuary management plans. And I will leave it at that. You can take a look at the map or the report, which will be released soon.
Yeah, thank you.
Thank
And
you.
thanks to the Oregon Ocean Science Trust for supporting this work.
Great.